Hey, I'm Pat, and in this video I will be going over CFrames. Just as a warning, I guess, I'm not exactly the most experienced with CFrames or like the best person you could go to for an explanation on CFrames, because it's really not my thing. I'm not really like a math person or anything. I'm just good at like coding and logic, but it's alright. I'm gonna show you pretty much everything I know. And I'm gonna also link a video to a more in-depth explanation of CFrames in the comments from somebody that is a little bit more intelligent than me. So the first thing I want to go over is what a CFrame really is. You can really think of a CFrame, what it's actually called is a coordinate frame, and really it's just a way of positioning objects in a 3D space. So obviously we have a vector 3 which has 3 values, x, y, and z, and that just controls its position. But we also have its orientation, right? And we also have which direction it's looking, right? So you can imagine a C-frame being a combination of all those things and a few other values, I believe. And it's very useful for positioning objects. And one thing to keep in mind is that the x, y, and z axis in the workspace is consistent. So if I if I move this part this way, say you can see its position changes on the z. So you can see its position is changing on the z, and this is actually C-frame right here. So it's kind of nice too. This didn't used to be here. They didn't used to have the C-frame in the property tab, so it's kind of nice to give a visual. Although it doesn't show all the values. Since C-frame actually has 12 values technically, I think it is, so it only shows 6 of them though. But you can see the Z is fixed. So if I were to rotate this part, say 90 degrees, this direction, and now I move it side to side, it's still moving on the Z axis. So the direction it's looking has no impact on where we move it as far as position goes, which can be kind of problematic when you're doing things like VFX or spawning in parts or teleporting, things like that. You kind of need to position things based on where something is looking, kind of thing, and that's where C-frame comes into play, where C-frame's more of based off of which direction a part is looking. So say for instance a part's looking this way, right? So if a part's looking this way, Z would be forward and backwards, so it would be Z would be positive in front of us and negative behind us, and then X would be positive to the left of us and negative to the right of us, and Y would just be the same because up and down can't really change. But that's something to keep in mind, right? So that's kind of the idea of how C-frames work. Hopefully that's a decent explanation, but C-frames are also a lot more than just position and orientation. They also give you things like, they give you a few functions which help you position things as well. So what I'm going to do now is I'm going to position a part, I guess. I didn't really think out any good examples for what I'm going to do, but say I have this part here and I want to spawn it in front of my player. We can't exactly just offset the vector 3 because it won't spawn in front of the part in front of the player all the time, because the player would have to be looking the right direction for it to work properly. So instead what we can do is offset the player's C-frame and use that C-frame to position this part. Alright, so C-frame is just another, what do you call it? It's just another data type. So it's kind of like a vector 3, but it has 12 values instead of 1. So I'm just going to use a local script for this because it's not too important as far as using a server and client here. It's just an example, and it makes it a lot easier if I don't have to use remotes. So I'm going to get user input service, and actually, you know what, I'm just going to use a tool. Screw that, I'm just going to use a tool. Starter pack tool, and now I can use a server script in here. So in this script we'll just call it part spawn. So say I want to spawn a part in front of the player. So what I'm going to do is I'm going to get our tool first. And what I can do is we're going to get when it's activated. And when it's activated, we know the tool is equipped, so that means the tool is a child of the character, because when the tool is equipped, it's a child of the character, so we can get the character easily that way. Local char equals the tool's parent. And now we have the character, so now we just need a way of getting the character's C-frame. And something to keep in mind is the character itself is not a part, it's a model, so it doesn't exactly have position or C-frame or orientation, so we can't go off of that. Usually what you're going to want to do is use the humanoid root part. It's like an invisible part, but usually it's not changed with animations and things like that, so it kind of what do you call it? It stays consistent, so it's not kind of like weird with the C-frame. So in order to offset the C-frame, what we have to do is usually with a vector 3 you would add the vectors together to offset them, but with a C-frame you will multiply. So we're going to make a variable called offset C-frame, and what we'll do is we'll get the character's humanoid root part, which is just if I can spell, no I can't. And we get its C-frame. Remember, it has a capital C and F, and that's it. So we got its C-frame, and now we need to offset it. So you offset it by using the multiply, and then we just create a new C-frame. Now there's many ways to create new C-frames. You can see there's 6 different pages. You could give it a vector 3 as a position and a bunch of other things. But the first thing I'm just going to do is I'm going to what do you call it? Just give it 3 values. So obviously the first 3 is just going to be X, Y, and Z as far as position. So if I want to put it to like the side of the player, I'd use the X, but we're going to leave that at 0. Y, you know, I'm going to make it want to spawn in the air a little bit. So I'm going to give it 2, which will move it 2 studs into the air. And then for the Z, I'll move it 2 studs in front of the player as well. And now what we need to do is get our part and clone it, and then set its C-frame to match our offset C-frame. So I'm going to store the part inside of server storage, and what I'm going to do now is I'm going to clone it. And then we're going to set C-frame to our new offset C-frame, and then we got to parent it to workspace lastly, of course. And I'm also going to add it to debris just to make it not be around forever. And debris service just deletes a part, or not a part, an instance after a set amount of time. So it will be 3 seconds in that case. So this should work. We got our tool, and I click and nothing happens. I don't understand. I forgot to turn off requires handle, because we don't have a handle for our tool. So your tool's events won't work if it doesn't have a handle, and requires handle is on. And it's still not working though. The parent property of workspace is locked. Excuse me? What did I do? That parent. Forgot to parent it. Alright, so I'm just gonna go over this kind of fast. So you can see it's kind of wrong. I got it wrong. I don't know why I always messed it up. So for some reason negative is in front, so I'll do -2 instead of +2, and I'll put it in front of player. So it obviously needs to be offset a little bit more, but it kind of works, right? So I can kind of build a tower if I really want to. If it was offset a little bit better, it'd probably work a little bit better. So set it to 3, whatever. It's still kind of too much, but you can see it kind of works. We can build a little tower, whatever. So that's kind of the basic idea of how a C-frame works as far as offsetting it. There's another thing, like say if we want to rotate the part relative to the way our character is facing, we would have to use cframe.angles, which allows us to pretty much offset its angles, kind of like the similar way. So say if we want to do offset its angle as well. So offset cframe equals offset cframe, and then we can just multiply it by cframe.angles. So you can see we got a bunch of different a ton of different functions you can use, but we're going to use angles right now. And angles actually use radians instead of degrees. You can see orientation uses degrees, which is like 90 degrees, 45 degrees, 180, but radians can go up to like 360 or whatever. I don't know, I'm not too good at math, I'm gonna be honest with you guys. But say if I want to rotate it like something on the x-axis, what I'm going to do is I'm going to use math.rad, and what that'll do is convert degrees to radians. So I'm just going to give it 90 degrees, so I want to make it 90 degrees on the x-axis, so I just use math.rad, which converts it to radians, right? So now when I go ahead and do it, you can see now the part rotates up, and you can see no matter which direction I'm facing, it's always rotated the same way up, and it's always in front of me as well. So that's the power of CFrame. If I were to use vectors, it would actually be very inconsistent and not work right at all, really. So if I wanted to do something like I don't know, create like a little explosion in front of me, or like a laser beam or something, you know, you'd need to use CFrame to use the player's CFrame to kind of make it relative. Or say get like a position, maybe like 20 studs in front of you, and then you want to tween like a projectile, like a bullet or like a knife to it, like a throwing knife. You get the offset CFrame and use that position to tween the part to that position, pretty much, right? So another thing that is pretty important that I want to go over, which I don't really have a good way of like demonstrating its use in this video, it'd be more useful in the next video, but lookvector. So CFrame also has lookvector, so you can think of lookvector as just a way of telling you which direction something is facing, pretty much. That's just what it is. So it's a vector 3 actually, but it's still kind of related to CFrame, because I'm pretty sure, yeah, CFrame stores a lookvector. Say I could do offset cframe dot, it doesn't let me, but say if I do cframe.new, and then I can do a lookvector, and it tells you the forward direction component of the CFrame's orientation. So pretty much just the front facing orientation. So what a lookvector is it's actually unit vector, and a unit vector is also a vector 3. So lookvector, unit vector are both vector 3s, and a unit vector is, say, just a vector 3 that its position, or not its position, its magnitude equals 1, which magnitude is pretty much the like the sum of it, I guess, right? So its max would be 1, so all the numbers together would only be able to equal 1, I believe, or something like that. I don't know, I'm not too good with math, I'm sorry guys, but that's what a unit vector is. And a unit vector really is just a way of getting orientation for something. It's very useful for things like raycast, where you want to pretty much shoot a laser in a certain direction, which is what raycasting is really, and things like that as well. So say instead of I really don't have a good a good use case for a lookvector in this video. Yeah, I didn't think that through too well, honestly. I should have thought of it better. I can't really, I don't know what I would have used for an explanation on that. So that's really the main things behind this. You can also use cframe.lookat, which allows you to make a C-frame which is pointing at a certain direction. So say we want to make our character point towards something. So let's get rid of all this, and now instead what I'm going to do is I'm going to say make my player look at this spawn point, which is pretty much 0, 0 in the world, right? So in order to do that, what we're going to do is use cframe.lookat, which is just another function of cframe.lookat. Our second value is where we want it to look towards, and our first one is our current position. So I'm going to use the humanoid report's position as the first one because that's our current position and we don't want it to really change. And then what we need to do is get the position we want to look at, which is the spawn location, and its position really is just 0, 0, or not really actually. So we'll just use its position, workspace spawn location dot position. And now we want to set the humanoid report C-frame to equal our C-frame that we just made, which is cframe.lookat. So it returns a C-frame using the position that we gave it, and it also uses the second position we give it to tell it which direction to look. And we don't need this part anymore. So I go ahead and run this. And you can see now if I click, it forces me to look at the spawn point. So this is good for something like a combat system where like you want to force a player to look at another player or things like that. Very important. And you can see since I changed my humanoid root part, it actually changes the rest of my body parts because they're all connected to each other with motor 6Ds, which pretty much just makes them connected, is a good way of pointing it. Even though this is a model, so all my body parts are individual, I'm changing the humanoid root part, which all the parts are pretty much connected to, which forces it all to change. And you can see my model also has a primary part, which is the humanoid root part, right? So if I wanted to move, say, another model and kind of position it, I would use C-frame to do so. So that's something I can actually go over right now. So say you have a model with a bunch of parts, like these parts. I don't know why I'm on so low, but I have these parts here, and say I want to move them around, but they're all individual parts, so I can group them together, or group them together. Wait. Big Bang group as a model. Still not used to these new icons, but now it's a model, and these are all my parts. And I actually have no way of really moving all these parts because each one of them is individual. So if I change one of their individual's position, then it won't affect any of the others' positions, right? So this is where something very cool comes into play. It's called a click detect, or not, what am I saying? Called pivoto, which is a method that models have. So say I want to make the model move to in front of the player, kind of similar to the code we had before. So if I just undo everything I did in here to pretty much like this is pretty close. We want to do -4, I guess, which will get us pretty good in front. But now what we're going to want to do is clone our model instead of our part. So we're going to clone the model instead. And now what we're going to do is use pivoto. So I believe it's just cloned part, or cloned model would be better. Cloned model, pivoto, you can see it autofills. You can see it takes C-frame as the first parameter. So we're just going to take our C-frame, which is pretty much the same as before, where we offset it 4 studs in front of the player, and we're going to give it to that. So what it'll do is it'll make it move to that C-frame, and it'll do all the calculations to pretty much like move all the parts inside the model to where you want it to, and it'll kind of use like the average center point of the model as kind of where to move all the parts to, pretty much. And now what we gotta do is just set the parent to workspace, and I'll add it to the debris service or whatever. So now say I go ahead and click, and you can see it puts all of them in front of me, but they're not anchored, so they all just kind of fall apart. But you can see I click and it spawns all three of them in front of me instead of moving just one of the individuals. So this is good for something like moving a player as well. So you want to move a player to a position or something like that, you would use pivoto. You could also use it to move models like I just showed, which is very useful because you won't always have like single parts that you can move at once. So that's kind of like the basics of CFrame. There's probably a few more things that are probably important that I'm not really going over right now, but I mean, that's really like the basics of what you need to know for CFrame. It's very useful. Obviously it's very useful for things like VFX and pretty much everything really. You need to know CFrame to do really anything like teleporting or gun systems, whatever. You kind of need CFrame. So I'm gonna ask you to make a script on your own now. Well, it's 20 minutes, I don't know. If you want to make a script on your own, I can give you the challenge of trying to make a character teleporter. Something to keep in mind is if you try and position the player's humanoid root part's position instead of its C-frame, like you try and change that instead, it can actually cause some weird bugs. I remember when I first started scripting, I tried making a game, and my game involved me moving a character into like an arena, and it actually had this weird bug where like their humanoid root part wasn't in the same position as their body, and they'd be like invisible to other players, like some kind of weird replication error. So it's very important that you use C-frame instead of position. It can cause some weird issues. So my challenge is, you know, just to make a very basic character teleporter, and if you want to take it one step further, you could try and make a obby checkpoint system. So basically what you would have to do is find a way of detecting when a player reaches a checkpoint and somehow storing that. You could use a table, or you could use instance values to do things like that, or attributes even. And what you can then do is listen for when the player dies. I would use the character added event, which tells you when the character is added to the game or created. Every time the player dies, their character is deleted and remade. So when they respawn, their character will be added, triggering that event. So I recommend using that event. And then once their character is added, then you can, you know, position their character to the matching waypoint or whatever, right? So that's a few things you could do after using this video, hopefully, or maybe in conjunction with my previous videos. Anyways, that's pretty much it for this video. Hopefully it helped you understand C-frames, even though I'm not really an expert with them or anything, but hopefully it was helpful. Thanks for watching. I'll see you guys later.